Okay, in this video, I want to run through one more right triangle practice quiz to get you ready for the quiz that you'll be taking tomorrow in class. Now, keep in mind that the only calculator you are permitted to use on the quiz is some sort of handheld calculator, and I'm going to be using the TI Inspire so that you can see it on my screen here. All right, in problem 1 and 2, we have to find the exact values of the 6 trig ratios, and in order to do that, you need all 3 sides. So I'm going to use the Pythagorean equation to determine the missing side length here, which happens to be a hypotenuse. And with just a little bit of algebra here, I see that the third side length is equal to 15. With our angle measure identified in this corner here, the opposite side length is 12, the adjacent side length is 9, and of course the hypotenuse is 15. So that's going to allow me to fill in this information pretty quickly. For the quiz tomorrow, I'm not really worried about you reducing these fractions. Just leave them as they are. Now in number 2, we have to solve for the missing side length. This time, however, this is a leg side. It's not a hypotenuse. And here I find that this missing side length is equal to 3. Notice that I had to use algebra along the way to isolate my A value this time. And you'll also notice that this math worked out really nicely. We ended up with whole numbers. In the event that you see a question on the quiz tomorrow that doesn't have whole numbers, then just be prepared to answer with a radical. And again, you don't have to reduce the radical. And I answered with these fractions because I recognized with the angle up here that the 4 is our opposite side, 3 is our adjacent side, and 5 is the hypotenuse. All right, in this example, all we have to do is find the measure of each side indicated, which happens to be this one. So this is a hypotenuse, and according to this angle measure, this side length is an adjacent side. So the trig rule that utilizes hypotenuse and adjacent would be cosine, or secant if you choose to work with it. I'll just use cosine here. Cosine of 58 degrees will be equal to 10.6 divided by x. Since our unknown is in the denominator here, then x by itself would be the 10.6 divided by cosine of 58, and we can go to our calculator and use it. Pay close attention. This calculator is set to degrees, so I know the computation will work. And I see a result of 20.0030. Keep in mind that we are rounding to 4 decimal places for tomorrow's quiz. And on this next example, rather than leaving the 12 in this position, that would just end up making the same type of triangles we saw before. I'm going to move the 12 over here so that we have a chance to use a different formula. Since the 12 is now opposite of the 48 degrees, then I should use sine in this case of 48 degrees equal to 12 over x, because that's our opposite over hypotenuse. X then would be equal to 12 divided by sine of 48, and that's because our unknown was in the denominator here. And when we go to the calculator, 12 divided by sine of 48 ends up equaling 16.1476. Moving on. Again, this problem is going to be kind of boring because we've seen one just like it before. So I'm going to switch the 3 and the x. I'm going to place 3 in place of the hypotenuse and x as our adjacent side. Now, relative to this angle, I have an adjacent and a hypotenuse side. So I'm still going to use cosine here. Cosine of 38 degrees is going to equal, this time, x over 3, since this should be adjacent divided by hypotenuse. And I chose to reorder this because the math requires this time, since x is in the numerator, to multiply. X will be equal to 3 times cosine of 38 degrees rather than division. And 3 times cosine of 38 ends up equaling 2.3640. And finally, this is kind of a tight triangle, but the 16 is down here in the bottom right-hand corner. We have an opposite side and an adjacent side, so this requires the use of tangent. Tangent of 66 degrees must be equal to 14 over x. With x in the denominator, then x would be equal to 14 divided by tangent of 66 degrees. And that should help you out with problems 3, 4, 5, and 6. Now moving on to number 7, this time we're looking for the angle measure. Keep in mind that we set these up just like we've done before. We look at our angle measure and consider the side lengths that are provided. In this case, we have an opposite and an adjacent side, so I know that tangent of theta, our unknown angle measure, must be 14 divided by 14. Theta by itself then would require an inverse tangent to solve, and we'll write inverse tangent of 14 over 14. If you recognize that 14 over 14 reduces, then you can use that as well, tangent inverse of 1. And on our TI calculators, remember, you jump into the trig menu, and then you can select any one of these inverse trig functions along the bottom row. We want tangent inverse of 14 over 14. I created that fraction in case you missed it by pressing the control button and then divide. That's what makes fractions. It's not necessary, but sometimes it's helpful to see. And the angle measure ends up being 45 degrees. And that should make sense to most of you. I think you would have seen this special right triangle in the past. When the two side lengths are congruent and you have a 90-degree angle here, then both of these remaining angles are 45 degrees. In number 8, we'll again use our tangent rule because we have an opposite and an adjacent side. So tangent of theta would be equal to, this time, 2 over 4. Theta would be tangent inverse of 2 over 4. And when using the appropriate trig menu, tangent inverse of 2 over 4 computes to be 26.5651. Keep in mind that when we're working with basic trigonometry rules, any plain trigonometry rule, we usually put the angle measure on the inside of the trig rule. And when we're working with inverse trig rules, we always supply the side lengths. When we supply the side lengths, we obtain a result that happens to be an angle measure. When we supply the angle measure, then we get a result that represents our two side lengths. Moving on to the final examples, in this case you're asked to solve the right triangle. This time we want all components, capital A, B, and C. which represent our angle measures, as well as lowercase a, b, and c, which represent our side lengths. Fortunately for us, some of that information is already provided. Capital A is 33 degrees, capital C is 90 degrees, and lowercase c, I'm going to call this lowercase c because it's across from angle C, lowercase c is 15 units in length. With just a little bit of math, we can compute this missing angle measure. That would be 56 degrees, because all three of these angle measures have to add up to 180 degrees. I'm sorry, 57 degrees. And also a shortcut is that these two non-right angles have to add up to 90 degrees. With the triangle completed, at least with all the angles complete, we can use a variety of different trig rules to identify a side length. I'm going to start with the 33 degrees that was supplied, and I'm going to go after this opposite side length by utilizing the hypotenuse here. I know that sine of 33 degrees requires the opposite side length divided by the hypotenuse. And this is really nice for me because A, the opposite of angle A, is simply equal to 15 times sine of 33 degrees. And while I'm in right triangle trigonometry mode, I'll start thinking about what it would take to find this side length. Well, this side length is adjacent to the angle, and I still have my hypotenuse, so I know that cosine of 33 degrees would equal b divided by 15, and b is equal to 15 times cosine 33. So I'll go to the calculator now and compute these last two results. And A appears to be 8 units long, and B is about 12 units long. And after I've written those down, I'm just doing a quick check here. The solution seemed to make sense. Across from the smallest angle is going to be the shortest side. Across from the largest angle is going to be the longest side. And across from the angle that's in between the two is a side length that's going to be in between the two. So these appear to line up very well with one another. I think I'm happy with the results. Okay, in this example, we see that angle C is 90 degrees. We know that side length A is 10.4. I know that this is A because it's across from angle A. And I know that side length, side length B is 9.8 units because it's across from angle B. In a bit of a twist, we don't have any angle measures, any other angle measures supplied, so we should have to go out and find them. Now we could find side length C before we find any other angle measures by using the Pythagorean equation, so I think I'm going to do that now. And with side length C, the hypotenuse determined, we could find any other angle measure. Actually, we didn't need to find the hypotenuse first, but we did, and that's okay. Let's go after angle A here. I have a opposite side length of 10.4 and an adjacent side length of 9.8. So I know that tangent of angle A must be equal to the opposite, 10.4, divided by 9.8. And I also recall that in order to get the angle A by itself, I must use an inverse trig function. So inverse tangent of that same ratio, 10.4 divided by 9.8, this should give me my A value. So on our calculator, tangent inverse of 10.4 divided by 9.8 appears to make an angle of 46.7014. And this is a measurement in degrees, by the way. We could find our missing angle measure because, again, all three of these angles will add up to 90 degrees. And more specifically, all three of the angles add up to 180 degrees, but more specifically, these two angles in the red box will add up to 90 degrees. So I'm just going to take the 90-degree angle and subtract my last answer. And I see that that missing angle is 43.2986 degrees. And if I do a quick check with the side lengths versus angle measures, here's our largest angle measure compared to the longest side length, our smallest angle measure compared to our shortest side length, and the angle measure in the middle of the two produces a side length that's in the middle of the two. So again, I hope that helps a little bit while preparing for the quiz that you'll complete today. When you are finished, please make sure that you take a look at the Algebra 2 section of IXL and navigate to section Y number 1, Y number 3, 4, and 5. Those would be fair game sections for me to assign next week. Good luck.